Today we are going to be doing the reciprocal functions. Reciprocal and rationals are the same thing. This is our second to last unit. After this we just have exponentials and logs left. I know.
Oh, you did 10.
What?
The unit.
I don't know. We'll see when we get there. All right. We're going to look at rational functions two different ways. We're going to look at it like today with these transformations, with the a, the c, and the d. And then we're also going to look at it with just one big fraction. All right, so you're going to see rationals two different forms. But today we're just doing the transformations, which is why it's so easy. For your a value, that's the number that's going to be on top. It's still going to be your stretch, compress, reflect, all of that good stuff. So if it's bigger than 1, stretch. If you're between 0 and 1, compress. And if you are less than 0, reflect over the x. All right, for the c value. Now, it's not technically in parentheses, but it is in the fraction. And so it's inside the fraction. So it's still inside, it's still opposite. So if it's a minus c, which way are you going? And if it's a plus c, and then the number on the outside, your d value, that will be your up and down. So if it's positive, you're going down. Now, the one thing that these rational functions have that we haven't seen before are the asymptotes. So it's going to have a vertical and a horizontal asymptote. The vertical one is at c. The horizontal one is at D.
Do we now have transitional letters?
Kind of, yeah. Alright. Go down here to A. If you want to graph this 100% perfect, you would have to use a calculator and get your table of values. Now, oops. No. When you're looking at the table of the values, and this is why I don't really like it, is because there's normally only two values that are going to be regular whole numbers. So for example, when I plotted 1 over x, I get -1, -1, and 1, 1. But if I scroll, everything else is a decimal. Does that make sense? So it makes it really hard to graph exactly. All right, and same thing if you go up to the negatives, everything is a decimal. So I don't care if you plot the points. And so if you want to plot it, you would have to use a calculator, enter it in the calculator, use the table, connect the points. All right. I don't really care if you graph it perfectly with the points. What I do care about are the asymptotes. So you do need to graph your asymptotes perfect. Okay? So the asymptote is coming from the c and the d value. Is there a c value on this one?
Yeah.
No. So your asymptote is at x equals 0. There's no number down here with the x. So vertical asymptote is at x equals 0. I'm going to draw my dotted line here at 0.
So if it was 5x, the asymptote would be 5.
If it was like x plus 5
Oh, okay.
or x minus 5. Your horizontal asymptote is the number on the outside. Right, your d value. Once again, no number there, so your horizontal asymptote is at 0.
Wait, I have a question.
Yep.
About that. So your C and your D value not only tell you like what direction it goes, but it also tells you the asymptotes?
Yep.
Oh, okay. Thank you.
All right, now, like I said, I'm not going to plot the points exactly, but I do need to figure out where my bananas are going to go.
But then, do they have to be dotted line?
No, you can do a solid line if you want. So we're going to look at the a value. Is my a value positive or negative?
Positive.
So if your a values are positive, you are going in quadrants 1 and 3, just like the parent function. If you look at the poster over here, they're in 1 and 3. Mm-hmm. So if your a value is positive, you're going in quadrants 1 and 3. If your a value is negative, it will be reflected, and you will go in quadrants 2 and 4.
That's crazy.
What is the difference between the parent?
Yeah. Domain and range are also super, super easy, and they because you're using all of the values except for 1. And that 1 is where the asymptote's at. So for the domain, I'm using all of the x values, bless you, except for right here where my asymptote's at 0. So we're going to say x cannot be 0. It can be all the other numbers, but not 0.
I said like. Never mind. I think that's like set or whatever it's called.
Set builder.
Yeah.
If you were to write it in Set Builder, which I know it says it on your practice, I don't care if you do or not though, but you would just you would say x is in the real numbers, but x can't be 0.
Oh, okay.
And so it's just a little bit more,
So we just write the x.
yeah, I'm fine with that.
So we don't have to put the actual dots. We have to do the asymptotes right, and we just.
Yep. For the range, it's going to be the same thing. The y values, you're using all of the y values except for 1, which in this case is 0. So we're not using this y value here at 0. So once again, you don't have to do Set Builder if you don't want to. At least get the x equals, or x can't be and the y can't be. All right, any questions on that one? All right, go to number 2.
Oh, you mean the ping, bruh. I'm sorry.
Okay, number 2. For the vertical asymptote, is there a number down here with the x? No. So vertical asymptote is still at 0. What about the number on the outside? Still no number, so horizontal asymptote is 0. So I'm going to draw my asymptotes. All right, now for my banana shapes. Is my a value positive or negative? It's negative. It's a -4. So are my bananas going to go in 1 and 3 or 2 and 4?
2 and 4. Which one's 2? Which one's 4?
This is 2 and this is 4.
It goes in a C.
That's a big one. You're a C.
They do it like 1.
All right, for the domain, what is the only x value we are never going to use?
0.
Very good. What is the only y value we are never going to use? Perfect.
So it's the same.
You know what? Nothing's perfect, ever.
Yeah.
Oh, I have a question about the reflection. Even though they're like the same exact kind of thing, how would they reflect? Do they reflect like
They would reflect this way.
that way?
Yeah.
Okay.
So like this
sideways.
one's coming, yeah, not sideways. This one's coming down, that one's going up.
Oh,
So,
okay, okay.
I have a question.
Mhm.
What if we move the line that dashes, that goes in the equation, and what if we put it over the 0? Would it mean the same thing?
Say that again?
I don't get it either.
No, say it again.
The dash
Uh-huh.
in the equation, no, where the D's and the R's go over. There you go. That,
Oh, yeah.
And you put it through the 0 instead, would it mean the same thing?
No. So a dash through a 0 means like no solution.
Mm-hmm.
But a dash through the equal sign means that x can't be 0.
Okay.
The 4, technically this is a stretch, but like I said, I'm not going to get that particular with graphing the points, so don't worry about the stretching. It's not a huge deal. The asymptotes are what's important here. All right, which brings us to part B, where we're going to start moving our asymptotes. All right, moving our asymptotes. So, for number 3, the vertical asymptote is the number on the bottom, but what do you have to remember to do?
No, it's gonna.
Because it's inside, so yeah, so we're going to switch the sign. So your vertical asymptote is at x equals -1.
Oh, that's what.
And then the horizontal asymptote is going to be what?
2.
2, the guy on the outside. So horizontal asymptote is at y equals 2. When you're graphing this, your vertical guy is going up and down at -1. Can y'all see that?
Yes.
And then your horizontal guy is going across at 2.
Yes, ma'am.
I thought this was my straw.
Okay.
High schoolers are there.
Very good. Like I said, my A is negative, so I'm going to have my bananas in quadrants 2 and 4. Now, for the quadrants, you kind of use your asymptotes as your new axis, All right, so just ignore the x and the y if your asymptotes get moved. This is going to be your quadrant 2. This is going to be your quadrant 4. Does that kind of make sense?
Yes.
It's like your new axis.
So it just moves the line.
Yep.
Let's go to Washington, D.C.
Okay.
again.
For the domain, what is the only number x cannot be?
-1,
And for the range, what is the only number y cannot be?
2.
Okay, let's do number 4.
Same color?
Oh no, I don't want that color. All right.
Can we get things done?
Where is my vertical asymptote at?
+2.
Positive 2. Where's my horizontal one at?
-3.
Good. So vertical 1 is here at 2. Horizontal 1 down here at -3. And my bananas, are they in quadrants 1 and 3 or 2 and 4?
1 and 3.
1 and 3 because it's positive here.
You don't do it right.
So 1 and 3.
That's crazy.
And for the domain, what is the only value we are not using?
2.
And for the range, what is the only value we're not using?
3. No, it's positive. Oh, yeah, -3.
All right, any questions, comments, concerns on graphing?
So
Sweet. All right, flip it over. We're going to skip 5 and 6 because I think we know how to do it now. 7 and 8. 7 says write an equation and sketch the graph for the translation of 5 over x. So, for this equation, I want to shift left 2 and up 3. So, where is left 2 going to go?
At the bottom.
At the
with
bottom,
X.
and it's going to be
-2. What?
+2 because it's moving left.
Oh. Never mind.
So, yes, the 2 goes on the bottom of the fraction on the inside, and because it's that inside guy, it does, you think opposite, so it's going to be +2. And then what about the up 3? Where does that go? +3 on the outside. Normally you don't see parentheses, just because they're kind of understood.
Sorry, I'm fancy. I wasn't raising my hand.
Okay. For your asymptotes, one of them is being shifted left 2, so we are going to the left 2. And the other one is going up 3, so we're being shifted up 3.
Oh my goodness.
Are my bananas in quadrants 1 and 3 or 2 and 4?
1 and 3.
1 and 3 because the 5 is positive.
Stupid. You want to call me stupid? Okay, is it always going to be a curved line? It's not going to be like a box line?
Yeah, it'll be curved.
It's curved. That's lame.
It'll be curved and it's going to get really close to your asymptotes. So make sure they don't loop away from your asymptotes. All right, it gets close to your asymptotes, like a magnet. All right,
But it never touches.
but never touches. For the domain on this one, what is the only x value I am not using? -2. What is the only y value I'm not using? 3. All right, go over to number 8 real fast. Same thing. If I am shifting to the right 4, where is that going?
Bottom and it's going to be
Positive or negative?
Oh,
Negative.
we -3.
-4.
I'm sorry.
So -4 on the bottom, think opposite, and then the down 3, -3 off to the side. So we're going to have an asymptote here at 4, and a horizontal asymptote down here at -3. And then for my bananas, are they going in 1 and 3 or 2 and 4? 2 and 4 because this -6. 2 and 4.
Yay.
For the domain, what is the only value x is not using? And for the range, what is the only value y is not using?
-3.
Very good.
Where's Bobby?
5. All right. Part C. This one we're just doing the translations like we've done all year. So everybody tell me what's the +2?
Up to.
Up 2. Didn't sound like everybody. Tell me what -4 is.
Right 4.
Right 4. Someone besides Faith, tell me what the minus sign is. Reflect. I think it's spelled reflect wrong. That's okay. And then the 3.
So great for
Stretch.
Oh, but y'all want to call me stupid. Okay. Andrew, what was that?
All right, Emery, what's this minus 3? Down 3, very good. Victor, what's the plus 5? Left 5, very good. And Brianna, what's the 2? Stretch. Perfect. All right, one last part and then we're done for the day. Part D says identifying the asymptotes, domain, and range from the graph. So I'm giving you the graph. We got to find the asymptotes. So Gip, where's my vertical asymptote at? 1. Evelyn, where's my horizontal asymptote at? 0. Angie, for the domain, what is the only value x cannot be?